In our previous video, we explored the discovery and significance of 3I Atlas, and now we're taking the next step, discussing what it would take to send a mission to chase this interstellar visitor. In July 2025, astronomers discovered Comet 3I Atlas, the third interstellar visitor observed. Moving rapidly through our solar system, it's set to pass closest to the Sun in October, sparking interest in a potential interception mission. In this video, we'll take a closer look at what makes 3I Atlas unique, the challenges of reaching it, and what future missions could learn from this interstellar comet. 3I/Atlas is the latest in a line of rare interstellar objects, and it's already sparking scientific curiosity. The comet was discovered on July 1st, 2025, by the Asteroid Terrestrial Impact Last Alert Survey (ATLAS) telescope located in Chile. It's traveling at an astonishing speed of 58 kilometers per second, much faster than most comets within our solar system. What makes it especially intriguing is that it's not just any comet. It's an interstellar one, meaning it came from beyond our solar system. The object itself is about 7 miles, 11.2 kilometers in diameter. While that may not seem huge by planetary standards, it makes the largest interstellar object observed to date. More importantly, the comet's size and composition are valuable for scientists who want to understand more about the materials that could exist in other star systems. It is composed of water ice, silicate minerals, and dust, all of which make up its coma, an active, gas-filled cloud surrounding the nucleus. As the comet moves closer to the Sun, its coma will grow and become more active, just as we've seen with other comets. Interestingly, 3I/Atlas's journey through the solar system is a first for humanity. It is the first time we've been able to observe such an object as it approaches our Sun. Earlier interstellar visitors like Oumuamua in 2017 and Borisov in 2019 were already on their way out of the solar system when they were discovered. This makes it an incredibly valuable target for study, offering a unique opportunity to learn more about what lies beyond our solar system. Its perihelion, or closest approach to the Sun, is expected on October 29, 2025, at a distance of 1.356 astronomical units, a bit farther than the Earth's orbit. The concept of chasing down a comet traveling at such high speeds raises some obvious questions. How can we catch up with an object moving 58 kilometers per second? What would it take to send a spacecraft to get a close-up view of 3I Atlas? A recent study from Michigan State University explored these very questions, looking into the feasibility of a spacecraft flyby. The study analyzed the possibility of launching a mission from either Earth or Mars. Launching from Earth, however, would require a massive boost in velocity, 24 kilometers per second, which is a significant challenge. To put that into perspective, this is nearly the same amount of energy used by NASA's Dawn spacecraft when it launched to study the asteroid Vesta. This high delta-v, or velocity change, would require advanced propulsion systems, and given the short window for launch, it would be difficult to build a spacecraft in time. Mars, on the other hand, presents a more promising option. The comet will pass relatively close to Mars in early October 2025, and a launch from the red planet would require only a modest delta-v of 5 kilometers per second, much more achievable with existing technology. This could make Mars an ideal base for any potential mission. Even if we can't land on Mars to launch the spacecraft, we could potentially use Mars orbiters, which are already operational, to help with the mission by imaging it. These orbiters, like NASA's MAVEN or the ESA's Mars Express, could provide high-resolution images of the comet, especially when it's closest to the Sun during perihelion. Timing is critical. Missing the launch window makes chasing it nearly impossible, highlighting the need to detect interstellar objects early. If we do manage to send a spacecraft to intercept 3I Atlas, what could we learn? The answers are vast and potentially groundbreaking. For starters, a direct flyby would give scientists the chance to study the comet's composition in detail. Earth-based telescopes have their limitations. Most notably, they can only observe the object at a distance. By sending a spacecraft close to the comet, scientists could analyze its isotopic and elemental composition in situ, allowing for a better understanding of its origins. Understanding the composition of 3I Atlas could provide clues to the material that formed other planetary systems. Since this comet has traveled across the galaxy, it could contain traces of material from an entirely different part of space, potentially revealing how planetary systems evolve elsewhere. The information we could gather from this mission would be invaluable, especially when it comes to understanding the formation of life. For example, we could examine whether organic molecules, key ingredients for life, are present in the comet's ice and dust. This could offer insight into how life may have originated on Earth and whether similar processes could happen elsewhere in the universe. Additionally, the study of comets like 3I Atlas could teach us about the role of comets in delivering water and organic compounds to planets. These objects are thought to have played a key role in delivering the building blocks of life to early Earth, and by analyzing them, we could learn more about how these processes might occur in other solar systems. "3I Atlas" gives us a rare chance to study material from beyond our solar system. Catching it is tough, but the insights could reshape our understanding of planetary systems and life's potential. Early detection is key, so let's keep pushing for faster discoveries and smarter missions.